like I said, 0 degrees is, and we did homework on this, is less than or equal to x is less than or equal to 360. And I said that's where we're going to sit when it comes to this curriculum. I'm going to ask you a bit outside of it as we go on because we're not going to write the test right away. We're going to write the test with the next unit because your cumulative's on Thursday, right? So this isn't going to, this little bit of trig we did, I'm not going to give a test on for another couple of weeks with rationals because I want to practice and extend. Practice and extend so that when you go to 30-1, you're like, yeah, this isn't so bad when everyone else is trying to do the trig. No, it's not on your cumulative. So your cumulative is only ever on stuff that's been tested on. So it's up to like the last test, the radicals and trig. But this stuff, this new stuff, can't be on it because it's not been tested. Cosine law and sine law, I know, but you should want to have it on your cumulative. Because it's easy. No. Your cumulative is X number of questions. It still can only be between 24 and 25 because that's all you can finish in a class. So if I gave you sine and cosine law, that would be 2 of them. It would be a much better choice, even though I haven't tested you on it, to want to have that on a cumulative. Yeah, the whole thing. Cumulative is just sine law and cosine law. No. Okay, I'm going to put it on because those are nice questions. Okay. So we have 0 to 360. Anyways. Number 1. So I'm going to have you solve. We're going to do sine x equals a half. So remember, when I give you like sine of 30, you would go to 30 and you take the y off the outside, correct? If I give you sine x equals a half, I want the angles. Oh my gosh, please put those away. You can't function, neither can anyone else around you. See?
And I'm the distraction.
That's just over. Okay. No. Stop. Okay. So sine x equals a half. It's a positive a half, so we can know where to go. It's a positive a half. Where is y positive? In quadrant, in quadrant 1 and 2. We can also use our CAST rule, C-A-S-T, and sine is positive here and here, in this quadrant and in this quadrant. So we're going to look for where y is equal to a half in those 2 quadrants. What are the 2 answers where that happens? 30 and 150. So I go x equals 30 degrees and 150. Boom. Okay. I'm going to give you another one. Go cos x equals negative root 3 over 2. What quadrant is cos negative, which is x? 2 and 3, because it's where cos, remember cos is positive at C and all. So it's going to be here and here. So you look and get me the answers. So we're looking where x is negative root 3 over 2. So where is that going to be? Where is x? Yep, Sam?
150 and 210.
150 and 210. Okay, so this is if they're nicely isolated as is. What if I give you this? So I'm going to give you 2 sine x plus 1 equals 0. So that's a lot harder to find currently how it is, correct? But if I had sine x equals something, cos x equals something, tan x equals something, I could find an answer. We agree? Okay, so what do I have to do first in order to solve? Get sine x by itself. So remember when we solved quadratics, we always had to get everything to one side, set it equal to 0, correct? That's when we solved a quadratic. When it was linear, we isolated the variable. When it was a radical, we got the radical on one side, everything else on the other, squared it, solved it, correct? When it's solving for trig, we have to get the trig function by itself. Because if I have sine x equals something, I can go to my unit circle and pull the value off, correct? So what's the first thing I'm going to have to move? Remember when I'm isolating a variable, I'm doing reverse BEDMAS. So what do I have to move first? The 1. I'm going to subtract 1. 2 sine x equals negative 1. Then what do I do? divide by 2. Sine x equals negative a half. Now you get me the answers between 0 and 360. Okay, so we use our CAST, C-A-S-T. Sine is negative, so it's here and here. So what are my two solutions going to be? What did you get, Nikki? 10 and 330, exactly. Okay, what if I give you this? You ready? So we get 4 sine squared x minus 3 equals 0. So it looks more intense, but I still have to do what? Just get sine x by itself, correct? I'm doing reverse BEDMAS. So I don't overthink it. I don't freak out. I just do what now? Add the 3. So I get 4 sine squared x equals 3. And then I do what? Divide by 4, because I have to do division. Then and only then can I do the exponent. So now what can I do? Square root. And we're going back to grade 10. We never leave grade 10. Grade 10 follows us into grade 12. Every single day in grade 12, I'll say, this is going to grade 10, and this was in grade 10, and this was in grade 10, which this year is painful because that was their COVID year. They're always like, every single time. In grade 10, you were taught that you can do a full radical or you can split them up. Now, can you do this one? Go root 3 over 4. Type that into your calculator, every single person. Type in root 3 over 4. You're going to get decimal. So humor me. Root 3 over 4, every single person, type it in. Okay? Now type this in. Root 3 over root 4. Splitting that radical up. Same answer, isn't it? So really what we can do every single time, whenever we have a full radical, we can split it up. If we have 2 split up radicals, we can write it as a full radical. They can go back and forth. Okay. So, when do you split a full radical up? You only split a full radical up into 2 radicals if one of them is a perfect square. So in this case, I'm going to split this up because the 4 is a perfect square. Do you see that? If both of them aren't perfect squares, if it's like 3 over 2, I would just leave it as full radical and call it a day if I wanted to. Okay? But one's a perfect square, I'm always going to split it. Now, I always get a plus or minus sign whenever you square root anything, right? When you take the square root. So I'm going to get sine x equals plus or minus root 3 over root 4. Now, why would I write them separately? Because root 4 is going to turn into what? 2. And is root 3 over 2 on your unit circle? Yeah, that looks a heck of a lot better. So we have sine x equals plus or minus root 3 over 2. Now, just so you know, how many solutions are we going to get now? 4. Go do it. So whenever you take the square root, you're going to get plus or minus. Whenever you get plus or minus, you're going to get 4 solutions. Do you agree? Okay. So what are my solutions at, Chloe? What are the solutions at?
61, 22, 43.
Because they're at all 60-degree reference angles, right? Because all the 60 degrees will have the same answers. Okay. So, that was 4. Here's 5. Say I give you tan theta minus root 3 equals 0. What's the first thing I'm going to have to do? Add the 3 over. So I get tan theta equals root 3. Now, when we get to the unit test, we're going to copy these down at the very beginning once we get our unit test. But we're going to go over tan 30, tan 45, tan 60, because we're going to try and find the reference angle that it would fall in. right? So tan 30, remember we're doing y divided by x, correct? So we're doing root 3 over 2 divided by 1/2. So I get root 3 over 2 times 2 over 1. These cancel and I get root 3, right? That's tan 30. What was tan 45? Do you remember? Yeah, it's plus or minus 1. This is for reference angles though, right? So it can be plus or minus because depending on where it falls, correct? But tan 45 is just positive. Because it would be root 2 over 2 divided by root 2 over 2. Do you see the y's and the x's on your unit circle? It would be root 2 over 2 divided by root 2 over 2, which is 1. And then the reference for tan of 60 is that really ugly long one, remember? Because you're going to do y, which is 1/2. Oh my goodness, guys, we back these backwards. These are so backwards. It's backwards! No one spoke to me. Backwards. Okay, we'll do tan of 60. Tan of 60 is the nice one. It's tan of 60 is root 3 over 2 divided by 1/2. I did x over y. Get the work.
Uh-oh. You're pranking us again.
I wasn't pranked, I just was dumb.
Oh, she said it good first.
Fully admit.
This letter is dumb.
I'm allowed to call myself dumb. Not
Source.
Okay,
Choose a wise.
y was 30, not root 3. What is y actually at 30? What is y actually at 30? 1 over 2. So it's 1 over 2 divided by root 3 over 2. So this is the long one. So it's 1/2 times 2 over root 3. And so we get 1 over root 3. And that rationalizes to? Root 3 over 3. So if you ever forget, you can figure them out algebraically, right? Okay, we're looking for which one though? What answer are we looking for?
Is it positive, negative, or it's
Well, your answers, these are, for 30 and 45 and 60, it would actually always be positive. But the reference angles can be positive or negative because depending on what quadrant you sit in. So we're looking for tan of root 3. Root 3 follows which reference angle? 60. So I know it's going to be a 60, but I have to figure out which quadrant it's in. How do I do that? So I know that this, root 3, gets me a 60 reference angle. And then I know I have to go to the sign. What is it? It's positive to get what quadrant it's in. So what quadrant does it sit in? This one here, I'm going to draw 60 because all are positive here. And then this one here, it's going to sit because all are positive, tan's positive here. So this one's going to have a 60 here, and this is going to have 60 here because that's the reference angle. Now we just need to get their angles in standard position. So what's the angle for this one? 60. These ones are nice. The reference angle and the angle are always the same, correct? How do I get to this one? Yeah, it's 240 because it's going to be 180 plus 60. So that's my two solutions. Theta equals 60 and 240. We're going to practice a whole bunch of tans so you don't make mistakes. Okay? Because I find the sine and cosine people are a little bit better with, and then tans it goes a little awry. So 6. We're going to go 3 tan theta plus root 3 equals 0. Isolate it. So we're going to get tan theta equals negative root 3 over 3 when we isolate it. Okay, root 3 over 3 goes with which one? 30, because that's what I should have got first, but I was dumb at the moment. And mix those up. Excuse me. Excuse me.
Podcast is still going.
Okay. Cat. Share this one with Nick Small. She belittles the teacher.
That's really weird. You called yourself dumb, Crystal. Oh, don't say that about yourself.
Yeah, now he's changing his tune. Did you see that? Okay. So we need tan negative. Where's tan negative?
second and fourth.
Isabel, you.
Tan is negative here and here. And what reference angle do we have? Our reference angle is 30. Okay. So this is 30, and this is 30. So where are my angles at? This is going to be 150 because 180 minus 30, and then this is going to be at 330. Please stop talking. So theta equals 150 and 330. Okay, what if I give you tan theta equals undefined? When does undefined happen? When you divide by 0. When you divide by 0. And tans are what divided by what? Y divided by x. So if I want an undefined, I need to find all the spots where x equals 0. Go find the spots where x equals 0. Oh, there and there, exactly. Yeah, perfect. Cool, cool, cool. Where does x equal 0? 90 degrees and 270. All right.
I'm gonna do my math game.